the next challenge was typo P, or thank you pop, or typop. It says, while writing the feedback form for IDEXCTF, JW made a small typo. It's still compiled though, so what could possibly go wrong? We're given a netcat port and a download file. So if we clear this, let's exit. If we do netcat, do you want to complete a survey? Yes. Did you like the CTF? Do you like the CTF? Yes, that's great. Can you provide some extra feedback? And we'll say IDEC was awesome. Cool. And it exits. I actually think there was a canary failure, but we'll talk about that a little bit later. So not too much. We're given a Docker file and the challenge binary. It says from pwn.redjail, some Ubuntu, make some directories, rename the challenge as server app run, add the flag file so we know where the flag file is, and then chmod and run this binary. Cool. If we load the binary in Ghidra, this is it. So it's going to do some buffering. Whoops. While true, do you want to complete a survey? If it's empty, quit, get character. If it's not, yes, break. Then it calls this get feedback function. It loads a canary value. If we do checksec, make Ubuntu, checksec file, we can see that it's full row canary, NX is enabled, Pi is enabled, so we have all the protections on. There is a canary. It's going to ask if we like CTFs. Then it's going to do a read. It's reading to this in buffer at a weird amount. I think this is 30 bytes. So it looks like we do have a buffer overflow. It's nice that it also prints out what we said. And printf will print until it sees a null terminator. So we're going to abuse that later. Then if it's yes, it'll say that's great. If not, it'll say all sad face. And then it asks if we want to provide some extra feedback. It reads in a bunch of bytes. I don't know how many that is. 90. And it quits, or it returns. Cool. We also have a win function. So it looked like the challenge authors were being very generous. We find out that maybe they're being a little bit evil. To call this win function, it needs 3 parameters. And if you look through, it's going to construct this file name by concatenating everything together. And this is txt period g. And so we need to pass in f, l, and a. And so this would be RSI, or RDI, RSI, and RDX. But if we can do that, it'll open up this file name and null out some bytes, and then do an fgets and a puts. So if we can call this function correctly, we win, and we'll get the flag. So it looks like we are going to be wrapping, and we need to do some arguments here. Anyways, so to solve this challenge, we're going to do, there's 3 main steps. The first step is we're going to go through this, and on this read call, we're going to add enough input such that we get to leak the value of the canary and RBP off the stack. So the canary usually has a null byte at the start, and printf will print until it encounters a null byte. So as long as we overwrite that null byte, and I think we do it with just an enter or new line character, we'll be able to get the canary and the RBP that's on the stack. So we'll leak both of those, and then on this read call down here, we're going to pass it back the canary, and because we need to set it to the correct value, and RBP to the correct value, or a nearby value. We're actually going to offset it a little bit. And we're still Pi is enabled and ASLR is enabled, so we don't know where the elf is in memory, but we can do a relative offset. So even though sections are randomized within memory, the last byte is always constant. I think it's actually the last 3 nibbles, but for us, you can't write a nibble, or you can't write half a byte. So we're just going to look at this last byte, and we can jump relative to anywhere this last byte is, and we know where it is. And so if we look at get feedback, it's called from main. So after get feedback returns, the current RIP on the stack is going to be this value. So we can jump anywhere that starts with 14. For our case, so right now, yeah, that very last byte is currently 47. We're just going to replace it with a 42, and so that we can call get feedback again. So we do that relative overwrite. We set the last byte, and so now we're going to do this function all over again, but we already have the canary and we have RBP. And so what we're going to do is we're going to, on this read and printf, we're instead going to leak the RIP that's on the stack. So we're going to read in, we're going to set a bunch of garbage, overwrite those 2 values, and then a couple of null bytes. When it does the printf, it's going to say you said blah, 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 and then RIP will be there, or the RIP that's on the stack. And then from here, when we do the read, we can actually, since we have the canary, we have a stack leak, and we have the base address, we can do some wrapping. So we would like to drop to the win function and we'll just set RSI, RDI, or sorry, RDI, RSI, and RDX to FL and A. But if we actually look through, if we dump Wropper out and look at what gadgets we have an easy RSI, so we can see pop RSI. We also have an easy RDI, pretty sure, yep. We have an easy pop RDI, but there's no RDX gadgets. So we have this SAL thing and this SAL thing here. And so that doesn't help us. So we don't have a way to set RDX. There were some calls in here during the program execution that sets RDX, but I couldn't find an easy way to get it to the value we want. So instead we had to be a little bit more clever, but not too much more clever, is instead we're just going to jump midway through the function. And we can see the fopen call, all it requires is RDI and RSI to be set. And we have easy pop gadgets for both of those. So we'll just manually set RSI and RDI. RSI just needs to be set to this value. So it's just the string that says R, so that's the read permission on fopen, and then we just need to set file name. So if we can get RDI equal to flag.txt, we'll just jump right here and we can win. Cool, so let's take a look at the solve script. Basically just going to do what I said. This is just standard imports, nothing too exciting. And we'll just attach GDB and start going through it together. Tmux, Python 3, solve.py. So like I said, the very first step, round 1, is we're going to leak the canary and RBP. So I did a break at getFeedback. So the start of the getFeedback function will continue. So we're at getFeedback now. It's going to set up some stack stuff. So I'm just going to do next a couple times, next. So it's going to call puts, do you like CTF? Cool. So if we look at the stack, here is the RBP. So this is the RIP that'll eventually be popped off. Here is our canary. You can usually recognize canaries because they have that null byte, but you can also do the canary command. We can see here's our canary, and then there's 3 values on the stack for this function. Cool. Let's next a couple times. So it's going to call read. This is the do you like CTFs call, I think, or do you want to complete a survey? Oh, and so then we said yes. So what's interesting about this yes, if we do stack 20 again, so we inserted a bunch of yeses. If we look, here are our yeses. It's at a weird offset. I'm not really sure why, but we got yes, and then we have this null byte at the end. If we remember earlier, that canary was, sorry, we have a new line byte now. It was a null byte. So when printf is called, it'll printf and continue printfing until it sees a null byte. And so the next null byte is here. Like these are padded obviously with nulls. So it'll print out the canary and RBP. So if we do next, so it's doing that printf, then it says you said yes, and then we have this value. So again, if we look at the canary, it's 5BC8, and we can see that, 5BC8, and it continues to A7. So here's our canary, and the next one is our RBP. And so if we see 7FFF, and that's pretty much where the stack is, 7FFF, AF, cool, so we leak those 2 values. So next we just keep going, then it's going to say, that's great, blah, 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 jump, load affected address. It's going to do a puts call, can you provide some extra feedback? So here, like I said, we're going to do that relative offset and overwrite the RIP on stack, which is the single byte. And so here's our payload. Looks like it was already sent. It's going to send flag.txt. It's going to send some null bytes. It's going to send the canary. It's going to send a close value of RBP. I'll talk about that in a second. And then it's going to send null, null, and then 42. So if we look at stack right now, when we're all done, it's going to jump to 47, 47 here. I might have messed up earlier. This is the RBP, this is the RIP. Whoops. But it's going to jump to 47. Currently it's set to 47, but if we do a next, stack 20, now we can see we're jumping to 42. And so just a reminder, that's in the main function. So normally after this function is done, it's going to jump to 47, but we just overwrite that last bit. And as a reminder, like I said, with Pi and ASLR enabled, these sections are loaded into random places in memory, but the last byte is constant. Actually, I think it's the last 3 nibbles, but you can't overwrite a half a nibble. You'd have to write over the bytes, so you're still brute forcing this one, but we don't care. We can jump anywhere that ends in 14. And so we're specifically just going to jump back to the start of this get feedback function. because we don't have a we don't have an info leak that tells us where everything is in memory. I mean, you can see oops. Yeah, so we can see it starts here, and you can see these last 3 bytes are just zeros, so that they're always constant. Anyways, single instruction, get end of get feedback. So it's going to load that RBP, reset RSP, and then we'll jump back, and we'll call feedback again. So at this point in feedback, we already have a leak for the canary and RBP, and so now we can leak our IP off the stack. So do you like CTF? Yes, 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 yes. So this time we're going to send yes, 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 yes. Then we're going to send, we could actually just send a bunch of garbage. We're not, the canary doesn't matter at this point. But we're going to send enough garbage such that when it does that printf, the next null byte is after the RIP. And we can see it here. So here's our leak. It said, you said yes, 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 yes. And then it gives us back our canary, a bunch of garbage, and here's the RIP. So it's 55F4, you can see that here, 55F4. So now we have an RIP leak, and we can calculate the base address for our ELF binary, where it's loaded in memory. Cool, and so now we have everything we need to start wrapping. So the next thing we're gonna do, it's gonna blah, blah, blah. Oh, that's great, you said. Blah, 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 it's gonna do puts, do you want extra feedback? And so now it's going to read, and it's going to read our ROP chain. So if we look at the ROP chain, we're sending it. So we're at this step. We have the ELF address. So we're going to create we're using PwnTools Wropper. The ELF address has been set correctly. So like I said, we're going to jump into the middle of the win function. And we just need to make sure we set RDI and RSI correctly. So RSI is the easy one. This is just that string that says R for the read permissions on fopen. It's just at a known offset. What did we say it was? 2008, so I think it's just G, yeah. Cool, it's right here, so it's just R. And for this one, we're doing RBP plus 47. For this, I just did a bunch of searching. Sometimes searching seems like it can be a little bit finicky, but let's see if it's working. Yeah, for some reason, I think it only reads one direction. I think it'll figure it out at the end, but if you search through, you can either do that or just do like stack 50. Eventually you'll find flag.txt written on the stack in a couple of different places. And I just tried a couple of different ones. Unfortunately, you'll see that I write flag.txt all over the place, that there, and here at the very end. And I also, when I return RBP, I also set to random RBP addresses. Like I said, this is during a CTF, so I'm usually pretty quick and dirty about this stuff. I just put flag all over the place, and then I calculate its offset from RBP, and I found one that works. Since we're doing this weird wrapping and we're setting RBP all over the place, it's very easy to get clobbered. The fopen call pushes a bunch of stuff on the stack. I think it uses like 40 bytes a stack, and because of that, it's very easy for the flag.txt to get overwritten. So you just push a bunch all over the place you can, and then just test a couple ones. And like I said, I found the one that worked for me was just RBP plus 47. I forget which one it was. Anyways, so we wrap. We set the 2 values based off of just searching the stack for a random flag.txt that worked. And then we jump to the middle of the win function. And then we send our ROP chain, and it should just work. So we'll do a continue. And cool, looks like it worked. So it jumped to the win function, and then it printed out the flag. So running it locally, but IDEC redacted. So fun little challenge. It's fun to string together all those bugs and get it working. It took a while for me to actually figure out what I was supposed to be doing. I was being silly, and I didn't realize you could leak RIP, and so I was trying to kind of brute force leak. So you can still jump even without an RIP leak. Like you can jump to 1320, but like I said, it's only these last 3 nibbles that are actually constant. You have I guess a 1 in 16 chance of getting this one correct. So I was doing that for a while and trying to like do a relative offset with RBP. The problem is that just everything kept getting clobbered. It wasn't until I realized later that you can do it again, get like a very consistent RIP leak and figure out the base address and jump coherently. And then I think the flag that I ended up using, the flag.txt I used was this one. So I put it at the very end of the payload because if you remember in our get feedback function, we're allowed to read in OX5A bytes. So that's quite a bit. And I think that one was far enough away from RBP and RSP such that it didn't clobber anything later down the line in our exploit chain. Like I said, very fun challenge, and thanks for watching.